It's a pleasure to be here. My current research focuses on applications of quantum anomalies in the context of gravity and cosmology. On the theory side, it was consistency of putting together classical gravitational theory with quantized fields, because we know that elementary particles, the theory of elementary particles, that's all needs to be quantized, and putting all that together is an interesting challenge. So that was the motivation on the theory side. On the cosmology and the gravity side, it's understanding of many interesting phenomena that are happening in our universe related to black holes, whether they are primordial black holes or the black holes in the modern state universe, cosmological perturbations coming from the very early stages of the universe, their influence on what we see in the sky, on the cosmic microwave backgrounds, and many other interesting observables. All of those questions together definitely motivated and continue to motivate my research. So many of those observations will be informing as to what's happening in gravity, what's happening in cosmology. I expect many people going into calculating consequences of modified theories of gravity for black hole physics, or in general in astrophysical settings in which gravity is very important, or calculating consequences of those theories for cosmological observables in the early universe as well as the late time universe in the problems that you mentioned for cosmological expansion, cosmological perturbations, issues of dark energy, dark matter, and related. It will have an impact in my field in general. There certainly are very complex circumstances in the development of the universe in astrophysics, in early universe cosmology, in cases in which direct computation or theoretical understanding is very difficult because there are so many time scales and distance scales. And in those instances, definitely AI will be very important. There are a number of groups that are very actively working on that, actually invoking modern day AI tools for cosmology and astrophysics, and that will continue to grow for sure. That said, there will always be room for more theoretical, more mathematical thinking, and a combination of the two, probably in conjunction with observations, obviously, will help us to make progress. It is happening more and more. Younger generation has different ways of learning stuff from us. We had books and we would do books. They are learning differently now, some ways more efficiently, perhaps not as deeply as we did, but that depth will come with age and experience. So they are more interdisciplinary, and they benefit from that, and we also benefit from their work on interdisciplinarity for sure. My advice would be for them to determine what excites them, what kind of work would interest them the most, whether it's observational work, experimental work, or theoretical or computational work. Once they know that, and if they want to be physicists, they for sure should be following where the experiment is, where they should be asking questions, where would you expect new data coming in. And whether then you work on that particular data or some theories around that data, in either case, that would be interesting. There might be some specifics related to the culture and the environment. That's all fine, that's all natural. On the other hand, the world is globalized. Well, science is globalized for sure. And the scientists in Ireland, they are very effectively communicating with scientists in the United States or even in Asia. There is very close connection, rapid exchange of information, moving back and forth for conferences and visits. That helps a lot to uniformize more or less the directionality of thinking, the level at which the research is done, and so on and so forth. So I would expect those national differences wouldn't play too much role. It is very important. There should be a spectrum of opportunities for younger people. Some of them would prefer to do exactly what you said, to take a risk, to think long on very difficult problems, and they should have an opportunity to succeed all the opportunities to succeed. And then there are others who may not necessarily care about that kind of approach, and they should move faster on something that's kind of emerging and quick and so on and so forth. So all of that is very valuable. So the funding agencies should be thinking very carefully and clearly about this so that they provide opportunities for everybody. Well, it's a great pleasure actually to work at the Simons Foundation. This is a foundation that's dedicated to fundamental mathematics and fundamental science. That's the mission, to develop basic science and mathematics. The people that work there were hand-selected by Jim and Marilyn Simons and their colleagues. It's a wonderful pleasure to be with them and work with them. The funding that goes through the channels that foundation adheres to embraces remarkable and very broad group of researchers, excellent researchers, and it's a pleasure to see and learn what they are doing, how they are making progress thanks to the funding that comes through the Simons Foundation. It's a very high quality conference. It always has been the case on every single visit to Hamilton Mathematics Institute in Dublin that I had. The talks are super interesting. I'm learning a lot. Looking forward to the remaining talks. I think I will have some inspirations. I expect that, yes.